Well, thank you very much for coming this afternoon. I'm very excited to talk to you a little bit about advanced task scheduling on Amazon ECS, and also to take some time to talk to you about a new open source project that we announced earlier today, Blox. To get started, for those who are not familiar with Amazon ECS, let me just do a quick overview of what the purpose of this service is and how we see customers using it. When we built ECS, our goal was to provide a highly available, high-performant cluster manager service for running containers. There's no software to install. We provide you with a set of APIs, and we manage all the cluster state and container state for you across our infrastructure. What we also then offer is flexible container placement. We have built-in schedulers that allow you to do long-running services or batch-type workloads. We see customers using a variety of both of those types of scheduling options. We also provide flexibility for you to use our APIs to build your own schedulers. Another benefit of using Amazon ECS is that we have deep integration with other AWS platform features. For example, we have integration with auto-scaling, ALB, ELB, IAM roles for auth, EBS storage, things of that nature, which really gives you the container a tier 1 integration with a deep ecosystem of AWS services. And the last thing is, by design, we've built Amazon ECS to be extensible. So it provides you building blocks so that you can model your applications and your architecture and run these on top of Amazon ECS. Perhaps you've seen this architecture diagram before. We've made this public. It gives you a sense of how we've built the service. At the core is our cluster manager. And we have an ECS agent, which is also open sourced. And that runs on the EC2 instances that you own. And that's how we are able to interact with your instance to our cluster manager and run the tasks for you. But really what I want to focus on today are two new significant components to this core platform. The first is our new ECS placement engine. And then also last week we announced the ECS event stream. And I want to talk through those and give you a little bit deeper dive into why we built them and how you should expect them to work. And then we'll talk about the further extensibility that you get now to build custom schedulers and really run any type of workload on top of ECS with Blox. So jumping into the task placement engine. Prior to the new engine that we're talking about today, customers were able to run tasks or a group of containers based off a set of constraints, and those were limited at that point to CPU, memory, and ports. Now what we've done is introduced a whole new set of constraints that you can use when you're making placement decisions. And you get these by default as part of the service. We provide you the ability to make constraints based off an AMI ID, off a specific availability zone, an instance type, and now we also offer several new placement strategies. The first is something that we call distinct instance, and we'll talk a little about what that means. And perhaps the most powerful piece here is we're also now releasing the ability for you to use custom attributes. So for example, you could say that you want to designate a set of instances within your cluster to be dev and the rest prod, and you can tag the dev instances so that you can now make placement decisions on these custom attributes. And really, you can use any sort of string to make these sort of placement decisions on now. So let's just talk a little bit about how we do task placement now with these new features. The first, you start with, in this example, a cluster size of 10 instances. The initial thing we do is look at which of the instances available to you in your cluster satisfy the CPU and memory and port requirements. After that, we take into consideration the new set of constraints. Perhaps you said only run these tasks on this specific AMI ID. Or maybe you want to run it on a specific instance type. You want to take advantage of a GPU, so you want to use perhaps one of our new GPU-based offerings or a G2, for example. You can make that as a specify that as a placement constraint now. Once we do that, we have another level that we'll talk about today that we call placement strategy. So that goes from I want to optimize for cost and utilization, so I want to bin pack all these tasks on a single instance. Or perhaps you want to do high availability and spread these across availability zones. You tell us the strategy for the placement that you want us to do, and we take that into consideration next. And at the end of the day, we get a subset of instances that meet the criteria that you've asked us for, and then we actually place the tasks on that subset of instances. So talking a little bit about the placement strategies, and we'll dive into each one of these individually and talk a little bit about how you can use these to run your applications. These are the 4 new strategies that are available to you. Bin packing, you can run all of your tasks targeted on a specific instance. And what we do is look at the constraint that you provide being either CPU or memory. And we'll pack as many of the tasks on a single instance as possible to really optimize for utilization. Spread, we had this before, but it was very random. It was randomly placed across instances within a specific availability zone. Now we give you more granular control to target specific zones within a region. So you may be, for example, running in US East 1, where we have 5 availability zones, but maybe only want to target spreading your application or service across 3 of those. You can actually specify which zones that you want to use for a given application. We also now support affinity and anti-affinity. So perhaps you have an application that you know is high CPU and another one that's high memory, and you really want to balance the placement of those to optimize how they run. You can go ahead and build your tasks so that, and use placement strategies to have tasks run together and be co-located on an instance. Or very commonly also you want to do something where you say, I don't actually want these tasks to run together because maybe it's your front end, your back end service, and you want to separate those for availability purposes or for scaling. Maybe they're running on different instance types as well. And the last is distinct instance, where you say, I have 10 of these tasks, and I really want these to run on a different instance. I don't want them to ever run together. I think another really powerful thing that we have in this release is something that we're calling strategy chaining. So you actually, and we'll talk a little bit about the query language that we've written that supports this, but what you get with strategy chaining is the ability to say, I want to spread my service across multiple availability zones, but within a zone, I actually want to bin pack this because I want the availability by being in multiple AZs, but I want to drive up the cost, the utilization, and lower the cost by running these on as few instances as possible within availability zone. So I think this is a super powerful feature that we're pretty excited about having for customers. So let's jump into a little bit, and I'll show a few examples of how this new query language works. This first example is matching on instance type. And I have 2 examples here because I think it's important to realize you can get as granular as you need to. So first, you can say that you want to filter for instances that match anything in the T2 family. Right? So that might return T2 small, T2 micro, T2 medium, our new T2 sizes. Or you can get as specific as saying, I actually only want this to run on T2 smalls. We also have the similar match on availability zone. So you can say, I want this to run anywhere in US East 1, or I really only want this application to run in US East 1A. Here's an example of how you can start putting these expressions together. So I want to run my task on any T2 in US East 1A, right? Or perhaps even more complex, I want to run on any T2 small, medium, or a GPU instance, a G2 instance, but avoid placing this, or don't place this in US East 1D, right? So we also take the negative expression there. And here's how you would set and then filter and eventually run a task on a custom attribute. So here you would associate an attribute with a target ID, which would be a container instance ARN. and then you would provide us with the key value. So in this particular case, we say, this is stack prod, and then you can see if I was running a development workload, I could say, run this on anything that's not in my prod stack. So let's go through a couple examples. I find this best if we can kind of visualize these together, and then we'll do a demo. So here is placement of a specific target instance type, so targeting a G2 instance. And this is a common use case that we hear customers ask us about. They have a specific application that they want to leverage a GPU, so now you can either use a custom attribute and tag your instances with a tag that specifies them as a GPU instance, or you can do this by instance family. And in this case, when you run that task, we will go ahead and find the G2 instances that meet the criteria that are available in your cluster and place the task for you. Here's an example of the placement by instance type and availability zone. So here in this example, we're going to avoid placing tasks in US East 1D, and we're only going to place tasks on instances that are of T2 small or T2 medium. And here is how you would, the command to run a task with a count of 9 and spread these across all availability zones. And you'll see the way we do this is we look for each, we make sure that as we start the task, we're doing this evenly across the availability zones in which you've told us that you want your service to run in. Here's the example that I mentioned earlier, I think super useful for if you have a service that you want to spread, but then actually optimize for cost. You would chain your placement strategies together and ask to spread the task across availability zones, but also bin pack on, in this case, we're bin packing on memory. A couple more examples. Here's one that I wanted to share because it shows that you can also run multiple, you can run these against the same cluster simultaneously. So here's an example where you would start specifying a placement constraint for on what we call a task group for your web server, and any tasks that were running already on instances in that task group, we'd go find them. So we'd place them on the same server for you. And then here's where we would say, on the second example, we want the backend piece of this application to not run with the web server. So place these in the task group that's not our web server. These same API capabilities are also part of our create service API. So you can choose to also provide placement strategies and constraints as part of the service definition. And then as we place these and run the service for you, we also continually, as you update your service and perhaps scale it, we follow the same and enforce the constraints and placement strategy as your service scales or as you scale in or scale down the service. So in this particular case, we're creating a service that is going to bin pack on memory, and at the same time run a service that is going to spread across availability zones. And so what we really want to demonstrate here is that these are all now part of the core set of APIs that you can use when you call either run task or create service as part of Amazon ECS. Here's an example where we're using distinct instances. So you may say, I want to target this task on GPU workloads first and just place, I had 3 tasks to start in this example. I only had 2 G2s that were part of my cluster at the time when I made the original service request. So we placed the 2. We respected the request to run on a distinct instance, so you didn't have a G2 available to start that 3rd task. But when a G2 does, perhaps you have an auto-scaling rule that then scales up your cluster based off that request, that pending task. As that then becomes available, we'll place the task for you. Same here, as your cluster scales, then we'll go and finish bringing your service to a healthy state. all of these features are also available in the ECS console. So if you would like to take advantage of these different strategies, you can do so. And there's a couple ways you can do that. The first is by using a placement template. And what we've done here is just taken common strategies that we've heard from customers are important to them, and we've created them as a template that you can select from a dropdown. So you can choose from availability balance spread. You can also bin pack, the example I showed, bin pack across an AZ. You can target a specific AZ and just bin pack your task, or the one task per host is the distinct instance constraint and strategy. Or you can create your own. And so we have a custom option, also through the UI, which you can just select both the placement strategies and constraints that are important to you and the priority, and we'll satisfy these as you build them in the console. All right, live demo, the fun part. Cool. All right. So here is a sample. Oh. There you go. So here's a sample run task call. I'll show you first. Here is my cluster. So I have no running task at this point. Here's a view of the availability zones that these instances are in. And in this particular example, I'm starting with placing 6 tasks on my G2 instances. And you can see, if you're familiar with ECS, as a standard output of our indicating that the tasks were placed successfully. And if we come back here and refresh, we'll see that we found the available G2 instances in my cluster and placed them on those. I don't have 6 G2s running. I only have 5, so we actually ran a second one on one of the instances. The second example is bin packing. So this example is going to show you us starting 5 tasks and running them on a single instance. And there you go, there at the top. So we've bin packed that application on a single container instance. And then one more. Here we're going to spread across availability zones and then bin pack within a zone. Let's try it. And so you can see these starting to come up here. So we've picked, and that's availability zone C, D, and then here's the US East 1D. So we've placed these across the 3 availability zones that I have specified and been packed within a single instance in each zone. So this feature, this new task placement engine feature, will be available in all regions that we have ECS today. And it's coming very soon. So we're really excited to get that out to you and very interested in the feedback they will get as you start using it. We feel very confident this will help give you great extensibility in how you, and control over how you run your applications across Amazon ECS. So the second feature I want to talk a little bit about today is one that we announced last week, which is the ECS event stream. The reason we built this service was because we realized in talking to customers that they wanted the ability to have real-time notifications of task state changes across their cluster. Excuse me. Prior, you could get this information by polling our APIs, and what we found is a lot of customers were doing that and then trying to materialize views locally so that they could run that close to their scheduler or build complex UIs. And that was just a little bit painful, and it was a lot more valuable if we can give them an option to consume events real time and based off actual changes in state across their cluster. So I want to talk a little bit about how this works. This feature is built on top of CloudWatch Events, another new AWS feature that was launched earlier this year. And so what we do is as a new instance or task starts up, we send an event notification to CloudWatch Events. And this is for all task state and container instance state changes. They go to CloudWatch Events and are stored there in a queue. The same goes for any task stop or termination or instance termination. If you terminate an instance and it has tasks running on it, we send you real-time notifications of those event changes as well. And then you can choose how to consume the events from CloudWatch. So they offer Lambda, Kinesis, SQS, and SNS as options for consumption. And we support all those as well. It's really easy to get started using this in your infrastructure. So here's one example how to use SQS, or SNS, excuse me. First, you create your CloudWatch rule, and you have a lot of granularity as to how detailed, how you want to set up that CloudWatch event rule. You can say, I want all events from all my clusters, and you may get a lot of notifications of task state changes across that cluster, depending on the type of workloads you're running. Or you can get very specific and filter down to, I'm only interested in stop notifications on a single cluster. In this example, since we're using SNS, you then create your SNS topic, and then you put your events to that SNS topic. So it's really just 3 steps to get started, super simple. And here's an example of how we see some customers already starting to use this. Here's an example where you can listen for event changes across your cluster and update your DNS zone Route 53 to do application discovery. So a new task starts. You can write a Lambda function that filters for a task start or task stop change for a specific application, and then makes the call to Route 53 to update your DNS zone. And so in this particular example, we have new records being added. Then we have a task stopping, and we would also handle that, and eventually remove that record so that your application would know that that service is no longer running. OK. So now let's talk a little bit about Blox. This is a project that we're very excited about, and looking forward to working with the community on collaborating. Talking a little bit about what is Blox. So today we're releasing 2 parts of this project. We have a cluster state service, and we have a Daemon scheduler. The goal of the cluster state service was to provide a mechanism for customers to consume events from the real-time events from the event stream and store them locally in a materialized view that they can then use a simple set of APIs that we're providing as part of the project to filter and list container instance and task detail. The second piece is a Daemon scheduler, and really we're providing that as a reference scheduler for you to see how you can build on top of the cluster state service and the ECS event stream. The reason we built this project to begin with is as we talked to customers, they loved the fact that we had built ECS and that they didn't have to worry about the cluster management. They liked the fact that they can use simple APIs to run services and tasks. But perhaps they've already been running containers for a while and have made some investment in existing schedulers, or they had custom business logic that they wanted to use as part of their scheduling. And we wanted to give them the control and the ability to do that as well. So with Blox, our goal is to offer customers the choice to how they run their applications, whether they're using the built-in schedulers that we provide with ECS, or if they want to run and build their own. If they have already invested in schedulers that they have using other frameworks, our goal is to make those extensible through Blox as well. And really, at the end of the day, we want to focus on how we can improve the end-to-end experience for developing and running containers on top of Amazon ECS. excuse me. So let me talk a little bit about how Blox works behind the scenes once you set it up. So events from the ECS cluster manager, again, as we showed, go through the ECS event stream. In this particular case with Blox, we've configured it to use an SQS queue. And when you deploy Blox, we set that up for you through a CloudFormation template. So we set up an SQS queue and connect that to your cluster that you want to pull events from. And then we run three containers, excuse me, as part of the Blox framework. The cluster state service, an etcd container where we store the state, and then today we have one container that's running the Daemon scheduler. It's pretty simple to get started, and if you're interested in getting set up and testing it, we'd love to get feedback from you. To get started, you can go to the GitHub page. It's online already, and clone the repo. Inside of there, you'll see a CloudFormation template that will go through the configuration and setup of the SQS queue, as I mentioned. And then you can simply start the three containers. And that should be it to get started. I wanted to show you a little bit of what the APIs look like that we have today in the initial release. Here with the cluster state service, you can get instance and task information and filter based off of clusters. And then on the Daemon scheduler, we've introduced some new concepts around creating what we call an environment and then a deployment. And really the goal of a Daemon scheduler, if you're not familiar with what the purpose of this purpose-built scheduler does, is it will target a cluster in which you've specified, and it will ensure that one task is running on each of the nodes in there. We also monitor for new nodes entering into the cluster, and we start the tasks on those as well. So if you scale up your cluster, we can guarantee that that task will run on any new nodes that join the cluster. So let's talk a little bit about that. So if you had a cluster of 3 instances, and then you ran Blox and started created an environment and started deployment, it would start those across the 3 instances, and then as new instances joined, we would see the event notifications coming through the event stream and start the tasks on those nodes as well for you. Here's what it looks like. So first, creating an environment. What we've provided in GitHub and available today is a demo CLI, so you can get an idea of how the service works. But as you look at it and look at the Swagger spec, you can also do calls against the REST API that we provide. So first is to create an environment, and once you've created the environment, as part of the environment creation, you specify the task definition that you want to run on all the nodes in your cluster. Then you create a deployment, specifying the environment. And here's a view of what it would look like inside the console. So you would have 5 nodes in your cluster. We would start the 5 tasks. And then as you scaled up, we would place a single task as part of that on each new node. OK, let's demo this as well. OK. So this, I wanted to just quickly show you the 3 containers that are running. We talked about them earlier. So I have these currently running on my laptop. One of the features with Blox is you can really run it anywhere. It does require connectivity to AWS because you're pulling events from the ECS event stream. But you could run this workload on top of an ECS container instance, or you can run it on your laptop, which I'm doing today. And let's go through the process. So here, I currently have no environments created. And I will go ahead and create an environment. So first I created an environment name. Now I'm passing in my cluster name. I have a task definition, my app. And now I have gotten a response saying that the environment has been created. We also give you a deployment token as a key to starting, and you'll need that to actually start the deployment. So now we're going to start a deployment. Provide the environment name, pass in the token, and now you can see that it's going ahead and started that. So if we come back to our console, we can see we had no tasks running, and now we see the task getting placed. And if we then wanted to come and scale up our cluster, let's go 10. So now what's happening behind the scenes is I have an auto-scaling group that's going ahead and scaling the number of instances in this cluster to 10. And what we want to eventually see as these start, we'll see the container instances register and tasks being placed on those. So while we wait for that, we'll come back and check on that in a second. Let me talk a little bit about our vision with Blox. It'll take probably a minute or two for the instances to actually start up. So really what we're hoping to do with Blox is create a direct channel of communication with our customers so that we can learn from you on what type of features you want us to build. And our goal is, as we learn more from you around how we can make ECS extensible, what sort of scheduling things are required to help you run your types of applications. Our goal is to eventually bring those sort of features back into the ECS core product as well. So really, we would like to ask that you take the time to test Blox, give us feedback. We have an open roadmap on our GitHub page as far as where we're going. We have a couple proposals out there already about how we intend to work to make what we've built already more highly available, a run anywhere type style. And we're very open to feedback from you on where you'd like to see the direction of the project go. Our focus really is on providing additional extensibility. We understand that customers have lots of different business requirements for how they run their applications, and we want to make sure that we're giving them the control and choice on how they run those on top of Amazon ECS. How can you get started contributing? As I mentioned, we have the GitHub page. It's all open sourced. It's licensed under Apache 2.0. Feel free to open an issue or a pull request. Comment on our proposals for the roadmap. We also have a Gitter channel that we've set up where you can interact with members of the team. And so if you have questions or on how to get started or comments on our questions why we've done things a certain way, feel free to ask those, and we'll have folks working and available to help there as well. All right. Come back here. Let's see how we're doing. And there we go. So we've got now all 10 of our container instances running, and Blox Daemon Scheduler was able to start a task across each of those. So just kind of in summary, we're really excited about the new features that we were able to talk to you about today. I think as you start to use them, you'll see that it really extends the powerful capabilities of Amazon ECS. Being able to make very detailed placement decisions and having direct control of how and where your applications run, really giving you the opportunity to make business decisions, both based on availability and cost, and down to the type of instances that your applications are running, is really a very powerful capability. With the ECS event stream, there's lots of different ways, and we'll be publishing more documentation and blogs on how you can take advantage of this. As we work with more customers, we're seeing really interesting use cases. People building real-time UIs on top of the event stream, and things like service discovery that we talked about today. And that's available already in all regions for you to consume. And then finally, as we really focus on how we can further build the extensibility and allow you to bring your own scheduling logic to run on top of Amazon ECS, we're really excited to partner with each of you and with the release of Blox. So I think that's pretty much. So I want to thank you very much for coming. And we have folks from the team here afterwards, so if you have questions, you can feel free to come up to the front, and we'll try and answer them for you. Thanks.